So you're coming up on a burn, and you would like to prepare for it. In this demonstration, we will show how to perform the preparations for a burn without actually igniting the engine. The engine ignition will be done in a different demonstration. So for this demonstration, we'll talk about the normal procedures. The first part of a burn is usually going to be the pad. The pad will appear when Houston has calculated it, and it will come up on the left side of your screen. Most burns will also require a state vector update. This burn, we can see, has a 6-4 deorbit purpose. So, same as the previous tutorial for a state vector update, you're only going to do both of the verb 37 enter 00 enters that the checklist tells you to if you're not in a PTC role. Then you're going to go uplink telemetry command module to accept. Simply wait for the comp activity light to come out, and you can tell Houston the computer is all theirs. Tab and 2. With the uplink now in progress, you can look at your burn information. We can see 8 hours, 57 minutes, 53.98 seconds. We've got a delta X of 3 minus 322.1, minus 0, and plus 374.9. Apoapsis of 152.6, periapsis of negative 35. Delta V compensated for 480.9, a weight of 32767. We've got our pitch trim and our yaw trim, our burn time, sextant star check, as well as our position check, our time of latitude and longitude, and the displayed latitude and longitude we should achieve, as well as our roll, pitch, and yaw, and any remarks that the burns have. So you could see we're getting a state vector update, as well as a burn target load, and a new refs mat. Whenever you receive a refs mat for your uplink, it's usually because Houston has some preferred attitude they would like you to have. So once the burn is complete, the next step is usually to run the P30 external delta V. And we'll be back once this uplink is complete. Okay, we got the uplink complete. Command module to block. Verb 37, enter. 00, enter. Now we'll move forward to the time in which we are supposed to do our P30 external delta V. If at any point you forget to copy a pad down and it gets overwritten by another pad, don't worry. Simply navigate to your orbiter installation and scroll down to the preliminary MCC preliminary advisory data text document. And this will have all pads for your current play session. Now we can insert the time or the information we were given. Verb 37, enter. Verb 37, enter. 30, enter. And let's see here. Why won't I get up the maneuver information? So I'm going to quickly pause and get that added to the screen. Okay, I have it added to the screen. And now we get in our program 30, 0633. We're going to verify that the time of ignition is as entered in the pad. Plus 00008, plus 00057, plus 053.98, or 8 hours, 57 minutes, 53.98 seconds. You may notice that this number will be 0.01 off. This is okay to have. This last row may be zero point zero 0.01 off, which is completely okay. This simply means that the computer has some sort of rounding uh, error due to the fact that it's an octal bit computer. So it must need to round to a different number to avoid data issues. Pressing proceed, and we get the delta x, delta y, and delta z right here. X, y, and z. They should be displayed in the same format as on the computer, minus the decimal. If all that information is correct, you may hit proceed. Now, the next information will be the predicted apoapsis, predicted periapsis, and our total delta V. The total delta V is not listed on the Apollo 7 pads, so just reference the compensated for cutoff and make your best guess as to if this is an accurate burn delta V total. And the program is still calculating, so I'll be back with you when that finishes. Okay, the computer now has its 0642 displayed, and we see 152.9 and minus 35. This may be a little bit off from the pad, but this is no problem at all. We see 494.3, which is very close to our 480.9 DVC, so this is good. Proceed, and we get our flashing 1645. The first row is important for rendezvous, and so we'll ignore it for now. The second row has the countdown, and the third row has our total velocity. If you get the countdown here, feel free to set it on the event timer. If not, feel free to do the calculation and set the event timer yourself once it's less than 1 hour. Now we can proceed, 00, enter. The next step is usually going to be a P52 IMU realignment. This could be preferred or RefSmat. Whatever the checklist tells you is what you're going to do. So I'll be with you once it's time for the P52 realign. Okay, we are back, and it's time for our P52 IMU realign to preferred attitude for this demonstration. And this is going to follow the exact same procedures as our other demonstrations, so I'm not going to explain much, but I'll simply do the procedures. One thing to note is that BMEGs must be set to rate 2 if you're on SPS, and CMC mode must be free if you're on CMC. And this is to stop the accelerometers from interpreting the gyrotorquing as a rate which needs to be corrected. '37, enter. 52, enter. Verb 22, enter. 1, enter. Proceed. Proceed. '25, proceed. And why won't I get this out of the way for you? Oh, we need it again. Star 36. Proceed. Mark. Proceed. Proceed. Star 37. Proceed. Mark. Proceed. Proceed. Good. Proceed. Proceed. Enter. 0, 0. Enter. Good. Now the next step is to perform the actual program 40 setup yourself. So I'll be back with you when it's time. Okay, it is time. The first thing that we're going to need to do is check the functions on our caution and warning system. All lamps are functional, the logic is functional, and the master alarms are functional. And that's it for that test. And now we're going to set our delta V. With the checklist may have you do a delta V test, but this one does not. So we'll just set our DVC. If you recall, the DVC is listed right here. 480.9. And set DV. Now we'll make sure we are on rate 2, low, with the SPS and in CMC control. CMC free, so we can configure our auto select. And wow, that sunrise is very pretty. Now we need to load the digital autopilot for the burn. Information for the digital autopilot can be found right here. So simply call verb 48, enter. And now Houston would like us to set verb 24, 11102, enter, 01111, enter. If it displays the same, the step is not required, but just for demonstration purposes and running through this program, I just show it off. Now we hit proceed, and we get our 0647, which is the command module weight and the lunar module weight. Insert verb 21, and insert the command module weight, if desired, 32767, enter. This is following the pad. And I meant to say, if desired, insert the lem weight. So if you're given a lem weight for this pad, insert it. If not, never touch the second row, because it's always more accurate than whatever guess you'll have if it is not provided on a burn pad. Once that's entered in, press proceed. And here's our gimbal angles. Insert verb 24 and set in the pitch trim first, which is minus 00073. Enter. And the yaw trim, which is minus 00015. Enter. Hit proceed and toggle the DAP with verb 46. Enter. And ensure that normal are on and up. Now we can set the event timer, which we can also call up by running through program 30. We can see we're still over an hour away, so we'll skip that. CMC auto. And now we need to maneuver to our pad burn attitude. Key in verb 49 for crew defined maneuver. Enter. And if you have your comp activity light on, you may need to wait a little bit for it to appear. Reset if operator error is flashing and you're flying Apollo 8 or 7. Key in verb 25 and enter the burn attitude, which is listed here. The format is plus, followed by the number, and 2 more zeros. Plus, followed by the number, and 2 more zeros. Plus, and followed by the number, and 2 more zeros. Proceed, proceed, and we'll enter our burn attitude. Once the spacecraft has entered the desired burn attitude, we can hit enter to clear this routine. And continuing on with the checklists, verb 37, enter, 40, enter. The same display will be brought up, but this time will be under P40 control, which is higher than the astronaut designated verb 49. Hitting proceed, and you'll transfer control from the verb 49 and the subsequent attitude hold right to program 40 guidance. Now we need to close the following circuit breakers. All stabilization control circuit breakers should be closed. Direct ullage for ullaging the engine. And all SPS circuit breakers should now be closed, including your pitch and your yaw. All SCS circuit breakers here should be closed. And all RCS circuit breakers, except for logic and command module heater, should be closed. EMS should be closed. And this is all that's required for the burn. And your stab control system here. Stabilization control system, bus ties here. Now ensure manual attitudes are rate command. These are set as displayed. Translation control on. And your SCS TVC should be on rate command for both. Your delta V center of gravity switch. LM CSM if the lunar module is attached. Just CSM if the lunar module is detached. At some point during your preparations, you'll also want to do a thrust vector control check. In order to accomplish this, batteries must be on, so you'll turn those on when the checklist prescribes. TVC servos must be on, and the rotational control power must be set to AC only. This is because, as you can see, the RCS is driven with the DC buses, main A and main B. If we're on AC, the thrust vector control is the only bus that's active, driven by both the main buses and the AC buses. This removes RCS firing while we're doing our TVC check. Setting BMAGs to attitude 1, rate 2, and spacecraft control to SCS, we can now manually control the TVC. Start pitch 1 and yaw 1. And feel free to bring those to 0 every time before you start a burn. It's just simpler that way. The translational hand controller Manual takeover mode must be engaged. Turn clockwise. And now
Rotation.
verify you are on rotation and do your 8213 and make sure that this gauge is not moving. Now set spacecraft control to CMC. Engage pitch 2 motor and yaw 2 motor. Now do the thumb wheel check. Minus, plus, 0, minus, plus, 0. And now set the GPI to the trim, which is right here. We have minus 7.3, so minus 0.567, and minus 1.5, which you can round up to minus 0.212. Right clicking does 0.1 at a time. Right clicking does 0.1 at a time. Left clicking does 0.5 at a time. Now we can do our 8, 2, release, 1, 3, release. And we can see this directly gimbals our engine. Holding control will let you do fine tuning. Setting the handle back to neutral, and she'll zero out. Now go AC/DC, direct power on in case we lose the normal systems. And now we need to transfer control of the attitude back to program 40. Go to rate 2 so that the attitude mode of the BMEGs is reset. Proceed on the computer, transfers control back to program 40, and set back to attitude 1, rate 2. Now you would perform the rest of your burn checks. But this is the end of our burn preparation and our test. So the next burn demonstration with the SPS engine will actually have an ignition using program 40 control. To terminate after the engine is done, or after the burn is done and you've nulled your residuals, verb 37, enter, 00, enter. You'll take your gimbal motors off, pitch 1, yaw 1, pitch 2, yaw 2, TVC servos off, batteries off, EMS off, attitude deadband will go to max, translation off, direct off, BMEGs to rate 2, and you'll open those circuit breakers you closed before. Note that in Apollo 7, the circuit breakers you'll open are only battery A. But in the rest of the Apollo missions, you'll open battery B on these 2 circuit breakers as well. Thanks for watching.